Hi, sixth graders. This notes page is going to be called integers. We're going to learn about things called integers today. I-N-T-E-G-E-R-S. Now, that's a weird word, so, say it out loud to yourself, integer. We're going to write down a definition and some examples about what exactly an integer is. So, if you think about a number line, so let's draw, I'm going to use one of these blue lines here right at the very top to draw myself a number line. You've had experience with number lines before, and what we're going to do is we're going to make a mark right in the middle. It doesn't have to be in the middle. It could be over here. It could be over here. I'm going to make a mark in the middle and put 0. And so far in your experience with numbers, you know that if we start here at 0, that right next to it would be a 1, a 2, a 3, and we're just going to mark with, we call these tick marks. So just mark with the tick mark and then write the number below. So 1, 2, 3, of course 4 and 5, and we're going to stop right there. Of course we could keep going, right? Because we go 6, 7, 8, 9, 10, all the way up to 100 million bajillion. It would keep going in this direction. No, 100 billion bajillion is not an actual number, but you get the idea. It keeps going forever. All right, so now let's look at what is happening on this side of the number line. Do you have an idea about what happens on this side of the number line below 0? Well, this is what we would call the negative numbers. And so if you're counting down 5, 4, 3, 2, 1, 0, the next number that you're going to come to is -1. And then -2, and then -3. And we mark negatives with this little line in front of them. -4, and let's go all the way down to -5. Now, of course, you could keep going, right? You could do -6, -7, -8, -9. So we call these, and I'm just going to sort of bracket this off right here. These are the negative numbers. Negative. And these are the positive. Now notice I'm not including 0 in this. These are the positive numbers. The numbers we normally use every day. These are the positive numbers. And these are negative. Now 0 is what we would call a neutral number. 0 is neither negative nor positive in the case of the number line. So 0 is kind of its own thing by itself. And so these numbers, the positive whole numbers, notice we don't have any decimals or fractions here. The negative whole numbers, notice again we don't have any decimals or fractions here. The positive and negative whole numbers make up what we call the integers. So everything you see on this number line plus everything that would go on out from it is what we would call the integers. Now we can talk about what we would call opposites on the number line. So if I point at the number 3, the opposite of 3 would be from 0, 3 is 3 units. The opposite would be, well, what's exactly on the other side of 0, the same distance away? So this is 3 units away. What would the opposite of 3 be? Well, it's -3. And same thing on this side. If I ask you what is the opposite of -4, it's, well, what is on the other side that is exactly the same distance? So that's 4 units here. So the opposite of -4 is 4. It just means either if you're on the positive side, switch to negative, negative side, switch to positive. So answer this, what would the opposite of 5 be? -5. What would the opposite of -2 be? It would be +2. And so the definition of integer, an integer is any negative or positive whole number and 0. Because remember, 0 is neither negative nor positive. All right. And so that's the definition of what an integer is. It's just negative and positive whole numbers. And so let's look at some examples of how we would represent these things. So an integer, here's what an integer is. We're just going to make a little box here. So let's just make, maybe scoot down a little bit, maybe make yourself 4 lines. So we're going to just draw a little box here that contains 4 lines down. And we're going to split this box down the middle, and we're going to write an integer is, and then integer is not. So let's look at some examples of what it is and what it is not. So an example of an integer would be -7. All right, -7 is a negative whole number. An integer would be 0. All right, 0 is included. 300, whole number, it's positive, would be an integer. Can you think of one? You can write down your own examples. 99 would be an integer. -99 would be an integer. Now, sometimes integers are disguised, and so let's look at an example of that. Another example of an integer might be 10 over 2. Now, I told you a second ago, 10 over 2, that looks like a fraction, right? And fractions are not integers. But this is a fraction that can be simplified. What is 10 divided by 2? Well, 10 divided by 2 is 5. So this is actually just a disguised integer. So be on the lookout as we're working through these. Be on the lookout for some disguised integers. Same thing if you did maybe, I don't know, -15 over 3. -15 over 3, well, what is 15 over 3? 15 divided by 3 is 5. I don't know why I chose 5 again. And it's negative. All right, so -5 is a negative whole number because this would simplify. So if you can simplify a fraction to come out to be a whole number, it is also an integer. So just keep that in mind. We want it to be negative or positive. All right, now some things that an integer is not. Of course, it is not fractions that can't be simplified to whole numbers. So like 1/2 or -3/4 or even decimals. So 0.4 or any kind of repeating decimal, 0.9 repeating, any kind of percent, so 55%, even though 55 is a whole number, with that percentage on it, it makes it a decimal, so it's not going to be an integer. So you could think of any fraction, decimal, or percent, even if it's negative, notice, even if it's negative, it is not going to be an integer. So those are examples of what integers are and integers are not. Let's look at comparing some integers, especially using our number line. So we know, looking back up here at the number line, we know that numbers that are greater go to the right, right? So the further we go this way, the greater. So I'm just going to label that. Greater numbers go this way. And so I could look at that and say, well, is 2 greater than 4? Well, no, 4 is further this direction, so 4 is greater than 2. And we know that we would get less the further we go to the left. And so if I look at 5 and I say, is 5 less than 1? Well, no, 5 is further this way, 1 is further this way, and so 1 is less than 5 because it is further to the left on the number line. So now notice that how that works with negative numbers, right? So negative numbers are going to get less when they go this way. That means -5 is less than -3. Now, we have always been taught that 5 is actually greater than 3. But the bigger the number, the more negative it is, and actually the less that it is. So let's do some comparisons between some numbers with some greater than or less signs. So we're going to compare. And so we're going to do 3 different examples. So we're going to compare 4, and I'm going to draw a circle so I can put my less than, greater than, or equal to in. So if we're going to compare 4 and -8, we're going to compare -2 and -10. And we're going to compare -1 and 7. All right, so let's look at these examples. So let's compare 4 and -8. Well, here's something that we do always know. We always know that a positive number is greater than any kind of negative number, right? A positive number is always going to be on this side of 0. Negative numbers are always going to be on this side. So positive numbers are always going to be greater. And so our alligator mouth is going to eat the positive number. Now, when we compare 2 negative numbers, we have to see which one is, which number looks the least, because the less the number actually looks, the closer it is to 0, right? So when we're comparing -2 and -10, negative 10 looks larger, but it's actually more negative. Think about where negative 10 would be on this number line. It would be down here. So negative 10 is much less than negative 2. You can also think about this as far as like debt goes. If you owe somebody some money, you owe them $2, or if you owe them $10, if you owe somebody $10, you have much less money than you do if you have negative 2. And so the arrow is going to point this way. Negative 2 is greater than negative 10. Negative 2 is a bigger number than negative 10. All right, down here, we also have, again, a negative that we're comparing to a positive. The positive number is always going to be eaten above the negative number. Let's do one more thing. Let's do with 0. Now, 0 looks like my circle that's in the middle, but that's a 0, that's a circle. Let's do 0 compared to negative 3. Now, 0 is not positive nor negative, right? But 0 is also going to be larger than every other negative number that we see here, right? So 0 will be eaten above any negative number. All right. Let's do one more where we compare two negatives. So let's compare negative 5 and negative 4. Now, again, 5 looks bigger than 4, but remember, we're dealing with negatives here. So which one of these is actually the bigger number? The bigger number, the greater number, is actually negative 4. And we can, again, double check this. So the alligator is going to eat negative 4. We can double check this on our number line up here. Negative 4 is actually greater than negative 5. Negative 5 is less than negative 4. So the alligator is going to eat the 4. So just think, for positive numbers, of course, you know how to compare positive numbers. But for negative numbers, it's actually opposite of what you think it should be. All right, so there is some comparison. The last thing we're going to do with our integer numbers is we're going to do some ordering. So let's see if I can move my camera down a little bit so we can actually see this. So let's order. Put these in order. Just like we did with fractions, decimals, and percents, we're going to order from least to greatest, greatest to least. We also looked at a vocabulary word in class a couple of weeks ago that dealt with the words ascending and descending, so I'll also throw that in here. So greatest to least, we're going to put these numbers in order from greatest to least. The words, the greatest to least could also be described as the word descending. So descending, if you descend stairs, it means it goes, if you descend stairs, go from up to low. So greatest to least could also be described as descending. So we want to order these in order from greatest to least. And so the numbers are negative 7, 6, negative 3, and 0. All right. And so we want to put these in order from greatest to least. So looking at the greatest number, out of negative 7, 6, negative 3, and 0, our greatest number is going to be anything positive. Now remember, 0 is not positive. It's neither positive nor negative. But 6 is a positive number. So in order, 6 is actually going to come first in this list. All right, and I like to mark them out as I go. So 6 is the greatest. Now we have negative numbers and 0 left. So once you get rid of all your positives, 0 is going to come next. And we could be looking at this on the number line. So 6 would be, of course, right here. We're going from greatest to least. So 6 is the first one we come to. Next, we're going to come to 0. Then we're going to come to any negative number, excuse me, any negative number that we need to. But again, it's going to be in the opposite order of what you think it is. So we're looking for 1s, 2s, 3s, 4s in that order. So out of, once our 0 is gone, out of negative 7 and negative 3, which one of those is going to be greater? Well, negative 3 is closer to 0. It looks like 7 should be greater, but these are negatives. They work in the opposite order. So negative 3 is going to come next. And then our least number, the number that's furthest away from 0, is going to be our negative 7. So in order from greatest to least, 6, 0, negative 3, negative 7. All right, let's do one more of these. And I'm going to have to move my camera so that I can actually see the bottom of the page. Here we go. All right, so we're going to do one last example, and we're going to do least to greatest. Least to greatest. The other word for least to greatest would be ascending. The word ascending means from least to greatest. If you ascend the stairs, you go from the bottom to the top of the stairs. So you might see that word as well. And so let's put these in order. Let's go with -2, 3, 10, and -8. All right, so in order from least to greatest. So now, and you can use your number line. Anytime you need to draw out a number line, that would be a great idea. We're going to go from least to greatest. And so we want to look for the negative number that is the most least, aka the bigger the negative number, the less it is. So which one in here is our largest negative number? Which one is the most least? We've got two, -2 and -8. The least would be -8. It is further to the left on the number line than -2. So of course -2 would come next. And then we get into positive land, which makes way more sense to our brains. And so 3 and then 10. 3, of course, is less than 10. 10 being the greatest, and so it is at the end of the line. So -8, -2, 3, and 10. All right, so for this integers unit, you need to know the position of numbers on the number line. Be aware of that positive and negative numbers, where they live on the number line. 0 doesn't have to be in the middle, but it can be. Greater numbers go to the right, less numbers go to the left. You need to know that an integer, being able to recognize an integer as any negative or positive whole number or whole number in disguise. Don't forget about those disguised ones. Integers are not fractions, decimals, or percents. Be able to compare them least to greatest. You can use your number line for that, and also put them in order from least to greatest. And that is what an integer is. Good luck with your practice.